Alright, so this day 4 one is an easier truss than day 3, which I went through the whole thing. If you have not watched that video, actually it's 2 videos because it's a pretty long problem at first until you understand it. You need to go back and watch that. Otherwise, you have very little chance of doing this. Even though it's an easier picture, imagine a 400-pound weight hanging on this part of a bridge. The most simple bridge you can have is just a triangle. So I know you can do this, and this is the whole wrench thing that you got to get good at. Just know when I write this, it's the same as writing the forces right equal the forces left. You can change them over. I kind of prefer this way. It's just saying the sum of all x forces is 0, which means they cancel out. Same with this one. When you see the force of the y's is 0 total, it's just saying the force up equals the force down. And then you make that work. So this is old stuff. Finding the angles, remember, it's the inverse tangent of y over x. Okay, so you're going to do that for angle A, and you're going to do it for angle C. Remember, you don't need angle B. You never need that top angle. You only need any angles on the bottom. So that was step 3. Step 4 is the free body diagram, and this is where all your answers will be. I am going to help set that up. So I want to, remember, with a pencil, or like me, an erasable pen, you want to redraw your original picture with joint A, joint B, and joint C. Okay, and instead of drawing the the roller, which has ray, and joint C has an up force, which is RCY, and it has an in force, which will probably be 0 because I don't see any horizontal forces. So you basically just want to draw all the things you know, and you're gonna know those 2 answers, those 3 answers, once you're done with it. So I got this up force here that I'll know a number for. I got an up force here, and not to spoil the surprise, if this is 0, which it will be, you don't have to draw that on there. And then this is how you do free body diagrams. Since we've only had one example of that, you basically draw the whole triangle and just erase the middles so you can focus on each joint by itself. So there's joint A, there's joint B, and there's joint C. So if I looked at joint A, here's how you know what forces are actually on these beams. If there's an outside force pushing up, the only thing that can battle that, remember I'm blocking these out, the only thing that can battle that force is a down force, and this guy can't create a down force, so it must be this diagonal pushing down that way. And every force, Newton's law, has an equal and opposite reaction. So if AB beam is pulling down this way, the only thing stopping it from moving is there must be an opposite force going that way. Okay, now we're still focused on A. Now I have a diagonal down and left. The down part fights this up, but now it's pushing left. So the only thing that can combat that is if this horizontal piece battles and fights to the right. And now you got the whole Newton's law. Every force has an equal and opposite reaction force. So this pushing in, it's in compression, so there must be a force pushing back. And I got my last one. You can do it a variety of ways. You could do this again, just like joint A. If there's an up, there must be a down somewhere. Or you could say up here, I have an up, so there must be a down somewhere. Anyway, we'll get that going. So here, let's see. That's got to be a down. Oh wait, this is an up. Oh, I forgot. That's why. There's a 400-pound force I didn't even draw. I'm like, how can they both be going up? Well, kg, that's because there's a 400-pound force going down. So those two ups will battle the one down. And you got some going right, some going left. All right, so you know you'll be done when you find FAB, the force on beam AB, the force on beam AC, don't pronounce that one, and the force on BC. All right, so I wanted to get that drawn for you. Go back to the other problems and attack one joint at a time. You can go joint A, joint C. I would avoid joint B. There's too many unknowns. But you can only do these problems once you figure out those numbers there. And the angles. We need the angles in. But that's the work you're doing over here, the prep work. Okay? And remember, when I see x is the sum of the x's equals 0, I've been saying force left equals force right. And the sum of the y's is when I say force ups must equal the force downs. Alright, so that's your setup, and you should be able to do it after that. Look back at that video on the more difficult one. This will be your first one you kind of do on your own. I helped you with the picture just because I know the arrows are a little confusing at first, but it's kind of nice. I like it because it's like little puzzles. Anyway, hope that helps. I will see you the next time you're in class, and we'll kind of look at the answer key and ask questions on it. All right, I'll talk to you later. Adios.